Hi guys, we're going to do the next chapter 8 video here. 8.2 is the section we're in. And today's essential question is, how do you tell if a parabola opens up or opens down? So how do you tell if a parabola opens up or opens down? And we're going to get into that real quickly here, but we're going to do a little review first. In the previous videos, we've been learning how to graph quadratics. We've learned what a parabola is, that smooth, like U-shaped curve. And before we can figure out if it points up or down, we need to do a little bit of review. So over on the side over here, I'm going to write review. And just kind of want to go over a couple of basics here, starting with order of operations. So order of operations is something you learn usually as a 5th and 6th grader. And the way order of operations works is we remember that a little saying PEMDAS, and people come up with all sorts of different sayings for this. You might have heard of "please excuse my dear Aunt Sally," or some people just call it PEMDAS, but all it means is parentheses, exponents, multiplication, division, addition, and subtraction. That's what it stands for, and it's the order in which we do our evaluations of different expressions. So here is a quick review. If I told you to evaluate, and I said, let's evaluate negative 4x squared if x equals negative 3. Order of operations is going to be kind of crucial in a problem like this. And the reason for that, the reason I'm saying that is because you're going to replace the x squared with a blank, but you're still going to have everything on the outside. So if it's negative 4x squared, it's going to be negative 4 blank squared. And inside that blank, we're evaluating negative 3. So we're going to be putting a negative 3. So order of operations says exponents and parentheses first. So we need to focus on this negative 3 squared. And a negative 3 times another negative 3 is a positive 9. So we get this positive 9, but we're still taking the 9 and times it by negative 4. So negative 4 times 9, well 4 times 9 is 36, but it'd be negative 36. And now we've evaluated. And I'm just reviewing this because when we're making our tables for parabolas, we often find order of operations is kind of crucial. Knowing where to put the negative sign and kind of how to go in that order is pretty important to what we've been up to. So keeping that in mind, I'm going to switch pages here so I have a little more room. We're going to review one more thing before we start diving into the plan for today, and that is we should know what standard form is now. So for quadratics, we have what's called standard form. And this is just how we write our equations. And we know that our standard form that we typically work with for quadratics is y equals ax squared plus bx plus c. And we saw this in a previous video. Now the ABCs are numbers. So a right here is a number, b right here is a number, and c is a number. And it could be any number, really. It depends on what the equation is. It could be 3x squared or 10x squared or negative 2x squared plus 7x plus 5 or whatever. But the whole entire reason we know this is called a quadratic equation is because its highest power is an x squared. And I'm just going to note that here. So if the highest power happens to land at an x squared, that's what makes this quadratic. And that's kind of how we know, oh, it's going to be one of those parabola graphs. It's going to be in that U-shaped form. The question is will it point up like this, or will it point down like this? And that's kind of our question of the day today. How could we figure out ahead of time before we do any work which direction it's pointing up? And we're going to figure that out with some examples. So let's try a problem. Alright guys, so we are going to graph two equations for our notes today to compare them, and they're going to be kind of some interesting ones. So the first one, in fact, to kind of give myself some room here, is I'm going to work at the top. So I'm going to write y equals 3x squared. That's going to be my first quadratic that I graph today. And the other one I'm going to graph is y equals, I'm going to go for a little more complicated one, negative 3 halves x squared. And we're going to compare these two to see what's the difference between them. So I'm actually going to basically build myself a giant T-chart so that we can compare the difference between these two graphs. And what I want to do is grab a ruler. I think I want to get this all set up pretty nice and neat. And I'm going to draw on both sides kind of a matching XY axis. So I'm going to just set up the basics. Here's my Y axis. That'll be good. Hopefully this will give me enough space to work. Here's my X axis. I'll put a little scale on here. Get myself kind of organized. And then I'll do the exact same thing on the right side. I just want these two graphs kind of ready to go so that we can compare them. I don't think I'll put any numbers on my graph yet. I think I'm going to leave it blank just to make sure I'm happy with my table numbers because I don't know what those are going to turn out to be yet. So there's my setup. Okay, so we got two graphs. We'll definitely, if you need to pause the video, go for it. But I'm going to move kind of into our 3 steps of solving. So step 1 is we need to find the vertex. So down below down here, for each of these, we're going to be finding the vertex. So step 1, where's the line of symmetry really, is what I'm going to identify. And I'm going to do that for both equations, both graphs. So step 1, vertex. Now to do this, remember the shortcut strategy here is to use a formula. To find it, we just use x equals negative b over 2a. That's our equation. So really, it's going to be negative blank over 2 times blank. Except we haven't identified what ABCs are yet. So we're going to need to do that. So I'm going to go back up and look at this problem. Standard form is always ax squared plus bx plus c. Well, I definitely see the a. A is 3. But I don't see the b and the c. That's because they are zeros. 0x plus 0. There's nothing there. So the b and the c are 0. And if you look at the other equation, it's the same story. Ax squared plus bx plus c. There is no bx plus c. It's 0x plus 0. Now the a is there. It's negative 3 halves. We do have a's. We have a equals 3 and a equals negative 3 halves, but we don't have b's and c's. So when I go to do my equation down here, negative b over 2a, negative b is going to be negative 0 over 2 times a is 3. But 0 divided by anything is going to be 0. So our vertex is happening at 0. And that kind of makes me happy. It means that on my graph up here, right down the center where 0 is also my line of symmetry. So I'm going to put it right there. And if you look, if we did the same thing for the other equation, x is going to equal negative b over 2a. We're going to do negative blank over 2 times blank. Remember what the ABCs for this one were. If you look up here, a was negative 3 halves, but b and c are 0. So b is 0, and then negative 3 halves. I don't really have to worry about doing all this math though, because 0 divided by anything is 0. So x equals 0 is also the line of symmetry on this graph, which means we're going to have pretty similar graphs with the symmetry fold line going right down the center on these. All right. Okay, well then if that's the case, making the table for step 2 I think is going to be not so bad. So that's my next move. Step 2, we are going to make a table. And we'll be doing that for each of these. Step 2, I'm going to make a table. Oops, what am I writing? Table, there we go. All right. Okay, so let's get these 2 tables all set up and we'll see what they look like. So I'm going to start with this one first. We're going to do x and y. Remember what our equation is. It's y equals 3x squared. And remember our symmetry is happening at x equals 0. So my table, 0 would have to be the middle number. So I'm going to go back to like -1 and -2 and forward to 1 and 2 like this. And if the equation is 3x squared, I'm going to be doing 3 times -2 squared, 3 times -1 squared, 3 times 0 squared, 3 times 1 squared, and 3 times 2 squared. Luckily, that should be pretty quick for me. A -2 squared is a +4, and 4 times 3 is 12. Negative 1 squared is just a 1 times 3 is 3. 0 squared times 3 is 0. 1 squared, 1 times 1 is 1 times 3 is 3. And 2 squared is 4, and 4 times 3 is 12. And these numbers don't surprise me because look, 12, 12, 3, 3. I'm seeing the symmetry. That's our first table. Now I got to make a table over here for the other equation. I'll do the same thing, x, y, kind of split this down the middle. This time y is equal to a little messier equation, negative 3 halves x squared. But that's okay, we can still figure it out. Again, the line of symmetry is at 0, so 0 is in the center of our table. So we got to go back to negative 1 and negative 2, and up to positive 1 and positive 2. And I'm going to go put each of these numbers in as carefully as I can. So if it's negative 3 halves, but it's times x squared, it'll be negative 2 squared. Or it'll be negative 3 halves times negative 1 squared. Or negative 3 halves times 0 squared. Negative 3 halves times 1 squared. Negative 3 halves times 2 squared. Okay, we got all our numbers in there. I'm going to do the easy ones first. I like to go for the easy stuff. The 0 squared, that's an easy one. 0 times 3 halves is all just 0. So at least I'm pretty happy with that. This one will be easy too. 1 squared, 1 times 1 is 1. So 1 times negative 3 halves is just negative 3 halves. And this might be the one time I'm like, I might want a decimal. 3 divided by 2 is, this would be negative 1.5. It might be easier to graph it as a decimal, negative 1.5, maybe. I'll put them both here so I have them. Now this one I have to do some math. 2 squared, 2 times 2 is 4. And 4 times 3 is 12. But then all divided by 2, so if this is 4 times 3 is 12 divided by 2, it's actually 6. And it's a negative 3 halves, so it's a negative 6. All right, not a bad number. Now if I go back the other direction, I already know what these other two numbers should be if I trust my math. If this is negative 1.5, so is this. If this is negative 6, so is this. And if I don't believe that, negative 2 squared is positive 4. 4 times 3 is 12. 12 divided by 2 is 6, and there's a negative sign, so negative 6. You can check your math. You can make sure. But there it is. There are our table values. Now, this left side graph has to reach 12. So I'm going to be a little more strategic up here. I don't think I made enough space to get up to 12. If I went 2, 4, 6, 8, 10, 12, I could count by 2s and it would work. So I'm going to go 2, 4, 6, 8, 10, 12, 14. I think I can just go 1, 2, 3, negative 1, negative 2, negative 3 here though. I don't think I need to do anything too crazy there. And we're going to plot the points from the table, which is way down below down here. So negative 2 and 12 will go on my table first. So I'm going to grab a different color here. I'm going to go to negative 2. I'm going to go up to 12, put my dot. For negative 1, if you look in your table, it goes to 3. So 3 would be between 2 and 4, so I'll put it in the middle. For 0, if you look in the table, you go to 0, 0. For 1, we're going back to 3, which is between 2 and 4. And for 2, we're going back up to 12. So there it is. There is our parabola. It looks like this. It is facing upwards. Just like that. Now let's get the other one on here. Now the other one didn't go to 12. We don't need such big numbers. I think negative 6 is the farthest we got down to. So if I have room to get to negative 6, then I'll be happy. Let's see. 1, 2, 3, 4, 5, 6. I do. So negative 1, negative 2, negative 3, just barely. Negative 4, negative 5, negative 6. Let's get the other numbers on here also. And we're going to plot the numbers from the table. That's the plan, is take those table numbers and see what we get. So again, let's see, we have negative 2 and we have negative 6. So negative 2, negative 6. It's way down here. The next one is negative 1, and that was the negative 1.5. So here's negative 1. 1.5 would be between the 1 and the 2, right there. And then we have in the table 0, 0. So here's 0, 0. And then we have 1 and negative 1.5. So we're going to go down to 1.5, right between the 1 and the 2. And then the last one was at 2 and -6. There's that reflection. There's our parabola. It's going like this way, facing downwards. Just like that. Sweet. Okay, so what do we got here? Well, here's what we have. We have two equations that we graphed. One is facing upwards, one is facing downwards. And remember, if you look back in your notes, if I grab my old page, we had written this down. We had said, okay, how do we know if something faces up or faces down? That was our question mark. Well, here's what it has to do with. If you look carefully at our two equations, they were very similar to each other. The only difference really is that the a coefficient, the number that's in front of the x squared, over here it was a +3, over here it was a -3/2. And that is the crucial difference. The positive coefficient points upwards. The negative coefficient points downwards. A tells us which direction the graph is going to point. If it's a positive, it's going to point up. If it's a negative, it's going to point down. So the part in our notes where we said, okay, pointing up or pointing down, that's our question mark. It all has to do with the a value. If a is greater than 0 and is a positive number, it's going to point up. If a is less than 0 and it's a negative number, it's going to point down. All right, guys, so this pretty much is the end of our video now. The final summary is we now know that a, if it's positive, the number in front of the x squared, the coefficient tells us that it's pointing upwards, and if a is negative, then we know it is pointing downwards. And honestly, it helps us check our answer, because if you go to graph and you have a parabola pointing down, you better have a negative coefficient. If not, you're like, I might have made a mistake in my order of operations when I was doing my table. So look at that a value, get kind of a clue of should it point up or should it point down, and it'll help you out with graphing. Thanks for watching, guys. I'll see you in the next video. Bye.